So STATA is one of the most powerful statistical data analysis softwares. Not only is it able to run basic analysis, for example, descriptive statistics, but you can also look at relationships between variables, and you can also run some basic and very advanced inferential statistics. STATA also has really good graphing capabilities, so you can develop your really nice looking charts in STATA as well. And the great thing about using STATA is it is very versatile. Instead of just using the graphical user interface to run your analysis or to develop your graphs, you can also run some commands. And those commands are really simple to write. The STATA command language allows you to run really advanced or even basic analysis or any other manipulation of data in STATA in a very simple way. And people love STATA because of the way that the documentation is laid out. It's extremely simple to learn STATA even within the STATA software itself by using the really nice and handy help command. We're actually going to be looking at that help command almost every time we're trying to use the software or running an analysis using any command, because it actually helps you to learn a lot about the software without having to go outside of the software. So the first thing that you see on the interface at the top is what we call the title bar. And what it does is it shows the name and the version of the software that we're using. As you can see here, I'm using version 13. But any version from 11 to the most recent version, version 17, as of the recording of this course, is going to work pretty well with the course. You also have the full path of where we have the data that I have opened up so far. Now, next to that, you have the menu bar, which lists all the commands that you can use in STATA. Opening any command from the menu is going to open up a graphical user interface through which you can perform that specific command. So most frequently used commands can be found here on the shortcuts toolbar. So for example, we have the open, save, and print button. We also have the button to open the log, or to open a new viewer, or to bring a graph window to the front. You also have the button for what we call the do file editor, a button to open up the data editor in edit mode, or the data editor in browse mode, and the button to see all the variables or the variables manager. You have this button here, which is called the clear more condition. And then finally, you have the break button. Now, we'll be looking at these commands in greater detail in later lessons. Now, the review pane, which is on the left here, acts as history of all the commands that you have run in STATA. So far, you can see that since I opened the program, I have run this one command here. Once I issue another command, whether through this command window down here, or through the graphical user interface, or through what we call a do file, that command is going to be listed here on the left-hand side. That is extremely important in case you want to run that command again. The big window that you have at the middle is what we call the results window. That's where all the output from analysis that you're running will be displayed, except for graphs. So graphs will actually open up in a new window called the graph viewer. We're going to look at that in later lessons. Now, below the results window, you have the commands pane. That's what we use to issue commands by writing them. Everything in STATA can be done by issuing a command by typing it in the command window. On the far right-hand side at the top, you have the variables list pane. So this pane will show you all the variables that you have in the dataset that is open at the moment. If this area is blank, what it means is that you don't have any dataset that is open. So which means if I try to run any commands that have to use data, those are not going to work until I have opened a dataset. And below that, you have the properties pane, which shows two things. So at the top, you have the properties of the variable that is selected at the moment in the variables pane. So for example, here I have selected safe water, and you can see the name of the variable, the type of the variable, and so on. You can also unlock this pane by clicking this lock or unlock button here, and that allows you to now edit the variable properties. For example, I can edit the variable name or the variable type and so on. I'm going to lock this back. Now, below that, you have the properties of the dataset itself. Here you can quickly see the number of variables that you have, the number of observations, and so on. Now, while working with STATA, you will notice a lot of windows popping up when you run an analysis or if you want to use a certain part of the software. For example, if I click this data editor browse window, you see that I actually open up this separate window called the data editor browse. Now, closing this is very safe, and that will take me back to the main window of STATA here. So as we are running some analysis or using the software, you will notice lots of windows that are going to be popping up, but notice that you can actually close those and go back to the software with ease. The sections that you see here, for example, the review pane or the variables pane or the properties pane, can also be unpinned or even completely removed from the main interface. So for example, I can close this variables pane like that, and you can see that it is gone. If you can't see a section on the interface, for example, maybe you closed it by accident, it helps to go to the window menu and then opening up that window from here. For example, I can bring back the variables pane by just clicking this variable window here, and now you can see that it is back. So since we'll be using commands a lot in STATA, let's take a look at how that is done. There are many commands that do different things in STATA. But maybe your first question is, how do I know what commands to use? I will be introducing you to many of the commonly used commands in STATA, but I will also show you how easy it is for you to find new commands and how you can learn more about them. So in general, you first of all need to tell STATA what to do by giving it the main command. For example, I can say here, summarize. Now, in many cases, that must be followed by the variables to be used for performing that action. For example, I have all these variables here. Now, to mention the variables, I have to use the variable name. So here it says variable. That's what we need to use. That's the variable name. So for example, here it says GNPPC. I have two options. I can either type it, or I could just go ahead and click on this little arrow here to bring it into the command. I'm just going to type it. So space GNPPC. Now you notice that we use a single space to separate each entry in the command. So after the name of the command, you put a space and then the variable name. If I have to put several variables, these also only need to be spaced out. Now, in some cases, you might need to specify some options. You have to first type a comma to separate the main command and the options. So here, let's type the comma. Now, when I put the comma here, STATA knows that what I'm about to write are the options. For example, I can say detail. Again, if I have to specify multiple options, I just need to space this out. I just need to put spaces between them. STATA will be able to figure out that these are different items in the command. And that's all. I can actually press enter. And you can see we have been able to summarize the variable GNPPC, which actually means GNP per capita here based on the dataset that we have opened. So in general, STATA commands will look like this. You have the command itself, then you mention the variable names, comma, and the comma is about separating the command and the options. And you can now provide the options, and everything just needs to be spaced out. Mind you, this is just a general layout. In some cases, you might see commands where you have to prefix a subcommand before the main command. And in some cases, a command cannot be complete without certain options being in place. We'll look at all this in greater detail in the course. And before I go, I must mention that commands in STATA are case sensitive. In fact, everything in STATA is case sensitive. So when I'm typing the commands, I'm going to be using all lowercase letters. If I type summarize with an S being capital letter, it's not going to work. So all the time, make sure that you are writing lowercase letters or exactly the way that the command is supposed to be written. And also the arrangement of the arguments or the parameters in the command must also be written exactly the same way that they're supposed to be written. And they must come in the same order as well. Otherwise, that command might bring you an error. And lastly, the variable names are also case sensitive. So when you're typing the variable name, make sure you type it exactly the way it looks like here. One of the reasons to use STATA for your analysis is how easy it is to find documentation of anything inside the program. We'll be doing this to learn further details for each command that we'll be using in this course. So in this lesson, I will introduce you to the STATA help and how to understand it. In the previous lesson, I showed you the summarize command for displaying summary statistics of a variable or multiple variables. To learn more about any command in STATA, in this example, the summarize command, just type help followed by the name of the command. In this case, summarize. As you can see, the viewer window has opened up, showing us that we are looking at the documentation for the summarize command. So what does the summarize command do? As you can see here, summary statistics. Then you have the syntax, which is the format in which the command must be written. I had mentioned the first part of the syntax is the name of the command itself. So in this case, summarize, followed by the var list. By var list, what it means is just type in the list of variables that you want to use. In some variables, it will just be var. That means you can only pass a single variable. Now, notice how var list is in square brackets here on the summarize command, just like the if, the in, and the wait, but of course, the options. When the part of the syntax is in square brackets, what it means is that that part of the syntax is optional. In other words, you can actually run the command without specifying anything in the square bracket. So in this case, it means that we can actually run the summarize command by just typing summarize without any of the things on the right hand side, and that is going to work. Based on the summarize command, what that means is it's going to summarize all the variables that you have in the dataset. In later lessons, we'll see how we can use the if and in statements to filter the data before the command is run. These options are available on almost all the commands that you can run in STATA. The wait statement is also part of many commands in STATA, and we'll talk about waits in later lessons in the course. Finally, we have the options here, which, like I said, they would come after you specify a comma. Immediately after the syntax, you have the breakdown of all available options for the summarize command in this case. Now, the help page also shows you how you can get to the command using here the menu, which gives you a much detailed description of the command and also a breakdown of the options. You have examples that you can use to learn more about the command. You even have a link here to watch a video that explains the command further. At the end, you have what you call the stored results. However, if you go back up, you notice that on the syntax, but also on the options, some part of the options or of the syntax are actually underlined. Those underlined parts are what you call the shorthand of that command. What it means is we don't have to write the whole word summarize. We could just simply type su or su, and that is going to pass as the summarize command. For example, here on the options, I can actually just say D instead of the whole detail, and that is going to pass for detail. Again, if I want to use the format option, I can just type F, and STATA is going to know that I mean to use the format option. So you will see me use the shorthand versions of the commands when I'm typing in the command window. It really helps a lot to make it easier for you when you're typing the commands. Before we dive into the statistics, let's first of all find out about data. As human beings, we're very inquisitive. In most cases, we ask a lot of questions. For example, maybe with the COVID situation, you might have noticed that there's a lot of dropouts in schools. So you were inquisitive, you want to find out what are the effects of COVID on education outcomes for kids. Now, for you to be able to answer that question, you need to go out and actually collect facts. You cannot just sit down and guess through the problem. This is where science comes in. We want to go out and collect some facts. So the individual pieces of facts that we collect for the sake of analyzing it, that's what we call data. We go out, so for example, in this case, I would go out and ask people or ask students to find out what has been the effect of COVID on their education. So I might have to ask certain questions. So those kind of questions that I'm asking on the students are what we are calling data. So this is going to come in terms of certain values. So for example, I might be interested to know the gender of the students. I might be interested to know the ages, the classrooms that they're in, maybe the income levels, and so on. I want to find out if they have had someone in their family who had COVID. So what happened after that? So those pieces of information that we're collecting, those pieces of facts that we're getting from our respondents, that's what we're calling data. So whether you call it data or you call it data, well, it's all the same. You're actually going to hear me say that interchangeably. So data actually comes in different formats or different types. So let's take a look at the different types of data that you're going to come across. So the first type of data is qualitative data, and this is basically data in form of words. So if you ask a question, for example, gender, the responses that you're going to get, the values that you're going to get are going to be in the form of words. For example, male or female. If I ask you, are you married? You're going to answer in the form of words as well, whether you're married or you're single or maybe you are divorced. So qualitative data comes in a way of words. But not only that, we usually don't have any specific or objective tool that we can use to measure the values. So for example, if you're asking, are you married or not, we don't necessarily have a measurement. We don't have a tool that we're using to actually objectively measure whether this person is married or not. Or if I ask you, what's your level of satisfaction of this course, then the response that you're going to give me could be in numbers or could be in words, but I don't necessarily have an objective way in which I can measure that. I don't have a scale somewhere, a tool that I can use to actually measure the level of your satisfaction. So that is qualitative data. So in qualitative data, we're mostly not describing things in terms of quantities. We simply have maybe groups of things. We're just mentioning names of things. So those names or groups of things, or maybe levels of things, that's what qualitative data is about. So let's take a look at the second type of data. The second type of data is actually quantitative data. And from the word itself, you can actually see quantitative. We're talking about quantities, right? So quantitative data describes quantities expressed numerically. So for example, if I ask you how old you are, you're going to give me your age in terms of numbers. So you're going to tell me that you're probably 20 years of age or 30 years of age. So that 30 there is a quantity of time. But it can also be, for example, what's the distance from your home to your nearest borehole? Or how many people are in the same room that you're watching this lesson? So because you're going to give me in terms of numbers, and these numbers are objectively defined. For example, if you're talking about age, somebody who's 20 years old in one country is 20 years old in another country. And the reason for that is because we have an objective way of measuring time. But also, if you say how many people are in the room, you're going to actually count the number of people. So we have an objective way of measuring that. So that's quantitative data, and the values come in terms of numbers. Now let's take a look at how data is collected. We now know that we have qualitative data and we have quantitative data, and that for us to answer questions about the world around us, we have to collect facts that we're calling data. But how are we going to collect this data? So there are two main ways in which data is collected. So we have what you call primary data. So primary data, this is data collected for the first time by an investigator for a specific purpose. So if I go in the field, or if I go to some respondents, some households, or let's say I meet some students and I'm asking them questions firsthand, then that is primary data. Or maybe you're getting your data from some experiment that you're doing. Because this is a fresh experiment that you're conducting. You're actually getting the data from the source itself, that is from the respondents or from the occurrences that are happening in real time. And that is what we call primary data. So this is data that doesn't have any statistical operations done on them. This is not summarized data. The data is raw, you just collected it from respondents, for example. That is what we call primary data. Now, we also have secondary data. So secondary data is data sourced from somewhere. So for example, if you go to your country's statistical office, they actually collect some data. But now let's say that they have analyzed that data, then that becomes secondary data. And you're getting information, you're getting facts from someone who has already summarized that information. We actually deal with a lot of secondary data from a daily basis. Maybe you're reading a newspaper article that is summarizing certain figures and facts, and you're using that in your reporting, or you're getting that and actually doing your own extra analysis. So that's what we call secondary data. So that's it about data. In the next lesson, let's take a look at what we call variables. So in the previous lesson, we've talked about data, and we found that data are pieces of facts that we collect for analysis. Now, these pieces of facts are going to come in the form of variables. So in this lesson, let's talk about the concept of variables. So what are variables? So variables are attributes that we are trying to study. So for example, let's say that we give a questionnaire or a data collection form to a number of students. We might want to ask them questions like, what's your gender, or what's your sex, or what's your age, or what's your monthly income, and so on. So those individual points that we are trying to collect are what we're calling variables. And variables are sometimes known as data items. So now let's talk about different kinds of variables. So variables are categorized in terms of the data that they contain. Remember that when you go, for example, to a respondent, for example, to a student, and we're trying to capture data from them, these data are coming in different variables, or they're coming in different items or characteristics that we're trying to collect from these individuals. So the data that is contained within a specific variable determines what type of variable it is. So in this regard, we actually have quantitative variables. So just like we have quantitative data, we have quantitative variables. So quantitative variables are simply variables that contain quantitative data. So an example there is going to be age. So if you're asking how old are you, and you were expecting the responses to come in the form of numbers or in the form of a number of years, then that is called a quantitative variable. On the other hand, we have qualitative variables. So these are variables or data items or the questions or characteristics that we are trying to collect on our survey or whatever data collection that we're doing that contain qualitative data. We have already talked about qualitative data and given examples such as sex or marital status or race or color. So those data items whose values are going to be qualitative in nature, then those are qualitative variables. Okay, so let's take a look at these variables in greater depth. So for example, quantitative variables, we actually also have different types of quantitative variables. So the first one is what we call discrete variables. So discrete variables, these are variables where the values are quantitative or they're numeric, they're numbers, but the numbers themselves are discrete, or the number of themselves are counts of individual items. So for example, if we say number of people, then that is a discrete value because you can never have a middle ground between 1 and 2. So you can never have 1.5 people. You have to count each and one of the items individually. So number of people, number of trees, that is a discrete variable. On the other hand, we have continuous quantitative variables. So these are measurements of continuous values. So for example, age, all right, or distance or volume. So these are examples of continuous variables. So these variables can contain values that are on a continuous scale. So for example, age, you can have someone who is 20.5 years old, or some, let's say distance, we can actually say 2.5 kilometers. So we are not necessarily going to just count each of the values discretely, but rather you can actually have values in between of whole numbers. In simple terms, in mathematical terms, discrete values are like integers. So while continuous variables can take other forms of numbers, not just integers. So maybe you can have decimals and so on. So qualitative variables, these are also known as categorical or grouping variable. The reason they're called categorical is because they mostly put people into categories. So for example, if we're saying marital status, we have people who are single and people who are married. So basically you have those two specific categories there. Or we can also call them groups, right? If you have sex, you have people who are male and then people who are female. If you have race, you know the categories that we put people under in terms of race. So because we put people into categories in qualitative variables, in most cases these are also known as categorical or grouping variables. Now the question could be, why is it important for us to understand the different types of variables? When we start to analyze data, you are going to realize that the type of analysis that you can perform on a variable actually depends on the structure of data in that variable. In other words, it depends on the type of variable that you're dealing with. There are certain analyses that are only applicable or they only work well with categorical or qualitative variables. And there are others that actually work well with continuous variables or quantitative variables. For example, if you're dealing with categories, right, you cannot do any mathematical calculation on categorical values. For example, you have gender, male and female. We cannot add them up. We cannot divide them up. So you can never do any mathematical manipulation on categorical or qualitative data. While on the other hand, for continuous variables, for variables that can take so many different values in a numerical scale, then you can actually do some mathematical calculation. And because in most cases for continuous variables, you have a lot of values. For example, age, you have so many different values in age. It's not appropriate to be counting each of the values that we have in the variable. While for categorical values, you only have a few values. For example, for sex, you only have male and female. It's very, very simple and straightforward to count that. If you have race, you only have a finite list of races. Or if you have colors that you are trying to collect, you may have just a group of colors. While if you go to, let's say you're talking about income, everyone is going to have a different value. If you're collecting so many values or you're collecting data from so many points, like let's say 100 or 200, you might actually have 200 very different values. In that case, it's not appropriate for you to be counting each and every one of them, but rather you have to do some mathematical calculation. So this is why it's very important for you to understand all this. But before we go, let's take a look at also different kinds or different types of variables, but this time by the role that those variables are performing in your research. So depending on what the variable is doing in your research, you can have two different types of variables. You have independent variables. So independent variables, these are variables that we think are the ones that are affecting the outcome of another variable. So let's take an example of a scenario where we're trying to study what affects the amount of rain that we get in an area. So you want to find out the factors that affect the amount of rainfall that we are going to receive. So those factors, for example, you might have wind, right? You might have temperature, you might have humidity. So those are variables that we think are affecting a certain outcome. In this case, the outcome is the volume or the amount of rainfall that we are going to receive. So those variables that we think are affecting amount of rainfall, those are independent variables. Actually, they are also called predictor variables, and I always like to call them predictor variables and independent. And the reason for that is when you say independent variable, it kind of sounds like they can never be affected. They are independent, they can never be affected. But that's not the fact, because independent variables can actually even be affected by other variables. So the better way to call them is predictor variables. So because we think that they are actually going to predict an outcome of a certain variable. In themselves, they could actually be affected by other variables as well. But at this point, we think they are predicting the outcome of certain values. That's why we're calling them predictor variables. Okay, so if you're structuring your research question or you're structuring whatever you're trying to find out, in the example that I've given you where we're talking about rainfall, what factors affect rainfall, so you're structuring that in terms of cause and effect, then what we are saying is the cause or whatever variable or whatever data item that you think is the one that is affecting the outcome of the other, that's the predictor. Now let's take a look at the other type. So the other type is a dependent variable. So this, if you have a cause, obviously you have an effect. So this is the effect. This is a variable that we think the values within this variable are going to change depending on what's going to happen with another variable. So the values, for example, the values of the amount of rainfall will change depending on the variables such as humidity, the temperature of the day, and so on. So the amount of rainfall is what we are studying, trying to see what would be the change in this variable and what variables are causing that change. And that's what we're calling dependent variables. We think that the values in the dependent variables are determined by the changes in the independent or the predictive variable. And we also call these as outcome variables. So when we come to the topic where we're going to be talking about cause and effect, for example, when we are doing regression analysis or analysis of variance, then we're going to be talking about predictor variables or outcome variables. Just think of them as independent variables and dependent variables. Or in other words, cause on one hand and effect on the other hand. One of the most important things that we need to understand in statistics before we can even start to analyze data is measurement levels. So what are measurement levels? So measurement levels are actually the relationship between the values within a variable. Remember, a variable is basically what's holding the information or the facts that we're trying to collect. So a variable can take multiple values or different possible responses. For example, if I ask, what's your sex? You could tell me whether you're male or female. If I ask you, are you married? You tell me whether you are single or you are married. So variables can take different values. Now, those different values, what is the relationship among those values? Now, obviously that's a book definition. Let's actually explain more about these measurement levels in a way that you understand very easily. But before you do that, it's actually extremely important to learn this because the choice of analysis that you're going to use actually depends on the type of variable, that is the measurement level of that variable. And it's very easy for us to understand at this point because we've already covered the types of variables like qualitative variables and quantitative variables. So the measurement of variables actually is a concept that is taken from types of variables. And we're going to be tying into types of variables when we're discussing measurement levels. So let's take a look at the different measures of variables or the different measurement levels of variables. Now remember, we have already said that measurement levels actually come from the types of variables, and we know that we have qualitative variables and quantitative variables. So in qualitative variables, we actually have nominal variable. So nominal variable is actually a measurement level of variable. Apart from nominal variable, we also have ordinal variables and we have binary variables. So binary variables, ordinal variables, and nominal variables are measurement levels under qualitative variable type. Then remember, we have quantitative variables. So quantitative variables can come in two measurement levels. You have ratio variables and you have interval variables. So let's dig deep inside of these different kinds of variables that we have talked about. But don't forget that we have qualitative variables, then we have quantitative variables. Remember, qualitative variables are also known as categorical or grouping variables. And quantitative variables are also known as continuous variables. And so within the qualitative variable types, we have nominal, ordinal, and binary variables, while within the quantitative variables, you can either have ratio variables or you can have interval variables. So let's start with nominal variables. So nominal variables are variables where the categories do not have a logical order. Okay, so these are categorical variables or qualitative variables, but the values themselves or the possible responses that you're going to get on a nominal variable do not have a logical order. You cannot put them in a logical order of, say, quantity or anything else. I'll give you an example of marital status. You can define marital status in terms of whether the person is single or married or divorced. Now, these three categories that I've mentioned cannot be arranged in some logical order. So you cannot say that there's something more to single than in married, or something more to divorced than in single. So these are simply names of values, or names of characteristics that you can give to people, or how you can describe people. As a matter of fact, the phrase or the name nominal, the word nominal, is actually coming from the phrase name only. In other words, the categories or the values that we are describing, the values within this variable, are just names of characteristics. They're just names that we are coining to certain attributes of the objects that we are trying to study. So examples of nominal variables can be sex, marital status, race, color. So every qualitative variable where the categories cannot be arranged in some order, we're calling that a nominal variable, or name only. So let's take a look at ordinal variables. So ordinal variables are variables where the categories have a logical order. So when you look at the values or the possible responses that you're going to get, you can actually arrange them in terms of a certain order. Okay? As a matter of fact, the word ordinal is actually coming from the word order. All right. So each category or possible value is actually a level of the variable. So I can give you, for example, satisfaction levels, or level of education, or level of agreement, or maybe other continuous variables that we just maybe decided to express them as categories. For example, there's people who actually collect age as age groups. So instead of actually asking how old are you and just recording the actual number itself, you're actually putting people into categories of age. So you can actually see, for example, if I give you an example of a level of education, let's say that you're collecting that as no education, and then you have primary school education, then you have secondary education or tertiary education. If you take a look at the categories here, you actually notice that these are in order. You actually notice that when we say primary education, we have more education in primary education as compared to no education. And if somebody actually went all the way to secondary school education, then you can actually say secondary education is actually more education than primary education. And also tertiary education, if somebody identifies as having gone all the way to tertiary education, then they have done much more education than one who has just done secondary education or primary education. So the values in this variable are actually ordered. And you can actually say that each category is a higher level of the variable. So for another example, let's say you're talking about satisfaction. And let's say that I ask you, how satisfied are you with this course at this point? And I give you the scale of 1 to 10. So someone who says that they are satisfied as a 9, that's obviously more satisfaction than someone who would say 6 or 5. So as you go up the categories, you're actually also going up in terms of the value itself. You're going up in terms of the quantity of some sort. But remember, these are still qualitative variables. These are still categorical variables. We're still putting people into categories, just that those categories can be ordered. So if you compare that with nominal variables, we're saying for nominal variables, the categories that we have cannot be ordered. All right, so let's now talk about binary variables. Now, binary variables are simply variables that have only two categories. So if you have a variable where the answer is yes or no, or on and off, or true or false, then that is called a binary variable, also called a dichotomous variable. Now let's move on to ratio variables. Now, if you remember, we have now gone from qualitative variables, now we're talking about quantitative variables. First of all, ratio variables are quantitative variables. So these are variables where you are actually collecting data that has been measured using an objective way or an objective tool for measuring it. These are continuous variables that actually also do contain an absolute 0 point or a meaningful 0 point. Let's take an example of number of people. Okay, so if you're saying there are 0 people, you actually mean that there is no people. The 0 there is actually meaningful, and it actually stands for an absence of something. So that's what it means by absolute 0. And the values also have equality of intervals. All right, let's explain equality of intervals in a bit. All right, so let's say the difference between 5 and 10 people, right? So if you have 5 people, then 10 people, if you subtract that, so the difference is 5. Let's move over on the scale. So if you have the difference between 20 and 25 people is also 5 people. So these two differences are the same, right? So if you are counting from a certain point to a certain point, if the difference is the same across different numbers that you're trying to subtract, then that is equality of intervals. There are certain values where you don't have equality of intervals. I'll give an example for ordinal variables. So ordinal variables don't have equality of intervals. So if you say that your level of satisfaction may be, you have numbers like you have 1 and 3. So someone who says that they are satisfied at number 3 and someone who says they're satisfied at number 2, if you subtract that, you have an interval of 2. But is that the same satisfaction, that difference of 2? Is it the same as the difference between maybe 8 and 10? All right, so it might not be the same because the value there is very subjective. It's not, you don't have an objective way of measuring it. So an ordinal variable doesn't have equality of intervals. While ratio variables, which are continuous or they're quantitative, they do have equality of intervals. So I've given you an example, for example, number of people, that is actually a ratio variable. Now, on the other hand, we have interval variables. Again, these are quantitative variables, but the only difference with the ratio variables this time is that although you have equality of intervals, just like the ratio variables, the ratio between two numbers is not meaningful. What does that mean? Let's take an example of temperature. Okay, so if you're measuring temperature in degrees Celsius, right? If you say that today is 20 degrees and maybe let's say 2 days later it's 40 degrees, you cannot necessarily say that it's twice the temperature that was 2 days prior. So 40 degrees is not twice the temperature as 20 degrees. And this is also very connected to something that we call the absolute zero. The thing about a variable like temperature is that you don't have an absolute zero. Let's explain this a bit. First of all, let's ask ourselves, what are we measuring when we are collecting data, say temperature? What are we trying to measure? So temperature is technically or scientifically is just the movement between atoms. So that is basically an equivalent of heat. So in essence, we are measuring the amount of heat that is in a certain object. That is what is called temperature. Now, if we say 0 degrees Celsius, it does not necessarily mean that there is absence of heat. In fact, there are certain objects that at 0 degrees, the atoms are actually moving. So 0 there is not an absolute number. So as such, the variable temperature, as measured in degrees Celsius, is not a ratio variable, but rather it's an interval variable. It does have equality of intervals, but however, it does not have an absolute zero. The zero there is not an absence of things and it's not meaningful. So I've given you an example of temperature, but another example that you can provide is pH. So pH is how we measure the acidity of objects. So when you say acidity is 0, that's not a meaningful 0. The 0 there doesn't really have any meaning. It doesn't stand for absence of something. The pH of 6 is not twice the pH of 3. As such, that is an interval variable. Now in SPSS, we are only going to see nominal variables, ordinal variables, and scale variables. So scale variables is just a bracket term for continuous variables or quantitative variables. So when we get to SPSS, you need to understand that for categorical variables, we have ordinal variables and nominal variables, while for continuous variables, we only have what you call scale variables, which is basically a bracket term for all continuous variables. So we're only going to be dealing with 3 types of variables. But you need to understand that the two, nominal and ordinal, are categorical or qualitative variable, or a scale variable is basically a continuous variable or quantitative variables, which could either be ratio or they could be interval variables. So in this lesson, let's talk about branches of statistics. This is just going to be a little introduction about the branches of statistics, but once we start doing analysis, we're actually going to go in depth talking about the different statistics that are actually under this branch of statistics that I'm about to talk about. But I think first of all, let's talk about what we call population and samples. Okay, let's take a scenario here. Let's say that you're trying to study the differences between using soft copy study materials and hard copy study materials on educational outcomes of students at your university, right? So now the students in the university become the subjects that you're trying to study. So interested to find out the differences between using soft copy materials and hard copy materials, but for all the people in the university. But because of several reasons, for example, you may not have enough money to be able to study all those people, but also because it's gonna take a long time for you to actually study a lot of people, then you might not be able to actually study all those people. So let's say that you have 3,000 students in your university. So that is what we call a population. So the population is basically the number of people that you're actually trying to study. So these people actually in most cases have one specific attribute that is common across all of them. So in our case, these are actually students in a university. So the attribute is that they are all in that single university. Now, this is the population that we have. But like I've said, you might not be able to study all of this. That's why you're actually going to take a subset of those people. You're just going to pick a few people and we call that your sample. So now your sample is just a subset of that population that now you're going to try to study. So just take a look at the definitions. A population is a complete group of people, objects, or items that you are trying to study. You wish that you could study all these people. In our case, all the 3,000 students in the university. But realistically, we're going to get what we call a sample. So a sample is now a smaller group of people or the objects that have been taken from that population that you are trying to study. So the population is going to be big, a lot of people who share one attribute that you're interested in. But because of several reasons that I've mentioned earlier, for example, cost and time, you're only going to pick a few people from that population, and that's what we call the sample. Statistics is extremely smart because it actually gives us the power to use a few people and study them, and then in the end be able to generalize across that huge population. So the group that we're calling the sample are the ones that are actually going to participate in the study. So for example, you might actually come up with some questionnaires that these people are going to respond. So the people who are participating in the study itself, that is your sample. But like I've said in statistics, statistics gives us the power to actually use the sample or whatever we're getting from this sample to actually generalize to that broader population. So now let's go into the branches of statistics. The first branch of statistics is called descriptive statistics. And as the name suggests, descriptive, we're using descriptive statistics to describe or summarize your data. And which data are we talking about? The sample data. That is the data at hand. So descriptive statistics is only about summarizing the data that you have collected. It's not about now talking about the whole population. The goal of descriptive statistics is to just summarize and describe the data that you have at hand. So we do that using the mean, the median, the mode, and standard deviations, even charts. We're actually going to be looking at these in greater detail in just a moment. On the other hand, we have what we call inferential statistics. So inferential statistics now uses the data that we have collected from the sample in order to generalize or to make generalizations to the broader population that we are trying to study. Remember, we wish to study all the students in the university, but because of some reasons we cannot. So we have drawn a sample. Now this sample is supposed to be representative enough. So there are ways in which we make sure that this is representative enough. Now, when the sample is representative enough, then we should be able to infer or to generalize whatever is going on in the sample to the broader population where the sample was taken. That's what we are calling inferential statistics. And examples of inferential tests include correlations, t-tests, analysis of variance, and regressions. And again, we are going to look at these in greater detail in this course. And remember, our goal here is to be able to choose the correct type of analysis we have to do, and then to actually do that in SPSS, to be able to interpret what's going on within that analysis, and in the end, to actually write our analysis or interpretation using the APA format. There are two ways in which you can bring data into STATA. You can either create variables and type the data directly, or you can import data from other programs. The most recommended way for bringing data into STATA is to import it from other programs such as Microsoft Excel. STATA is not a data entry software. It is very terrible at data entry functions. However, there will still be some scenarios where you need to enter some data in STATA. That's why in this lesson, I will show you how to do just that. Now, before you can enter data in STATA, you must first create the variables. I will show you two different ways for creating variables. One is by using the graphical user interface, and the other is by using commands. Before we move ahead though, it is important to know that you cannot have a variable that does not have any value in STATA. That means every time we are creating a new variable, we must assign it to at least a single value. In simple terms, as we create a variable, we are also going to be entering the first record of data. Creating variables using the graphical user interface is the easiest, but it takes several steps. First, we need to open up what is called the data editor window, but in edit mode. And that's this button right here. So the data editor is where you can see the data that we are using. When you open it in edit mode, we will be able to add or to edit data. Now, this is the data that we'll be entering. We want to create our first variable called ID. So in the data editor, we will enter the first value for ID here, which is 1. And then I press the tab key. Now, let's see what has happened. Here in the data editor window, a new variable called var1 has been created, and it has a value of 1 in row number 1. If you take a peek at the STATA main window, you'll notice that the command behind the operation we just did is generate var1 equals 1 in 1. Generate is the command used to create variables. var1 is the name of the new variable that we are creating. Now, this 1 here is the value that we are assigning to the variable var1, and that is going in row number 1. So in 1 means in row number 1. Let's create the next variable. For that, I'll enter the first value of the next variable, which is name of respondent, and that value is Peter. Then I'll press the tab key. Once again, a new variable has been created. Now this time it says generate str var2 equals Peter in 1. And this means we are creating a variable that's generate. And to be specific, it's a string variable. That's the str here, where the value in row number 1 is going to be Peter. So obviously we need to change the names of the variables. To do that, we will select the first variable on the right-hand side, right here. And then in the properties pane, we click on the name, and then we're going to type the correct variable name, which is just ID. Then I press enter. And now notice what has happened here. So the variable name has changed there. It has also been changed right there on the data itself. But again, we have the command based on the action that we have done here. And that is rename followed by the variable name. That is the old variable name, which is var1. then followed by the new variable name, which is ID. We can do the same thing with the other variable. We just have to select it, then go into the variable's properties on the name. Then let's change it to name of respondent. And we have an error. There are rules you must follow when creating the variable names. First, the variable name cannot contain any spaces. So that's the problem that has happened here. When I was typing the name, we actually included spaces. But it can also not start with a number. It should only contain letters on the alphabet, numbers, and the underscore. And make sure that the name is short and readable. So let's click OK. And now we're going to type the correct name. I'm just going to call it name. And then I press enter. So again, it says rename var2 into name. In the next lesson, we'll continue creating variables, but this time we're going to be using commands. To create variables using commands, we use the generate command. Before we try an example, let's check help. So in the command window, we type help, followed by our command, in this case, generate, and press enter. So here it says generate creates or changes the contents of the variable. We are mostly interested in the syntax here. So instead of typing the whole command generate, we can just use the shorthand G. In fact, the shorthand here actually means we can type anything from the letter G going this way. So I could just say GE, or I can say gen. So in most cases, you'll find people using gen, which sounds much closer to generate than just G. The next thing we can specify is the data type of the variable, followed by the name of the variable. After that, we have the option to set the label of the values contained in the variable. So for example, if you have the variable sex and you have a name of a set of values where you are assigning 1 for male and 2 for female, then you can set that here. We'll look at creating and setting value labels in another lesson. Then we must indicate the equal sign and specify the expression here. The mathematical expression that we set here can be just a single number like we have seen in the previous example, in the previous lesson, or it can be some calculation based on existing variables. We'll look at that in later lessons. After that, we can then use the if statement to filter the data before the calculation gets to be done. And finally, we can use the in statement to indicate the rows that will be affected by this operation. In the previous example, we have seen that when we say in 1, it means that the value we are assigning to the new variable will occur in just the first row. We have several different variations of the generate command here, but we are not particularly interested in those at the moment. One of the most important information here, though, are the data types that we can specify, which is what we can see indicated right here. So everything from byte all the way to double, those are different types of numerical variables that you can specify. So str all the way to str2045, those are types of string variables or text variables where the number at the end is the maximum number of characters allowed. For example, if you need a text variable with 3 maximum characters, you can use str3 as the data type. Typically, it's not necessary to mention the data type of numerical variables. In most cases, this is going to be set automatically. Now, we have all the information that we need to understand from here. So let's close the help window. And now let's go to the main window where we're going to see how we can create variables using the command generate. The next variable we need to create is age of respondent. So in the command window, we'll type generate, then space, followed by the name of the new variable, which in this case, that will be age, then equals, the first value in the first row is going to be 20. Then we have to say that that value is going in row number 1 by saying in 1. Press enter. And perfect. You can see on the right hand side, we actually do have the variable age. And if I open this data editor in edit mode, which we can also open by just typing edit in the command window and then press enter, you can see that it actually says 20 and the variable name is age. I'll just minimize this. So every time we want to go to the data editor in edit mode, we can just use the command edit. Now, the next variable is sex of respondent. We'll be using 1 for male and 2 for female. So when data is being entered, we'll just be entering the numbers. But then later, we'll see how we can set values to represent the numbers 1 or 2, which in this case will be male and female. So we can type generate. I'll just use a shorthand gen. Then the name of the variable, sex, equals, the first person is male, so that would be 1, then in 1. So generate sex and then assign the value 1 in row number 1, press enter, that has been done. And then finally, let's create education level attained. We will just type it as a string variable. So we can say gen. Now for string variables, we must specify that the type is string. So str space, then the name of the variable, I'll just call this education equals, then I put in quotation marks, primary, then close quotation marks, then in 1. So once again, what we are saying is generate a string variable with the name education and give it the value of primary in row number 1. Now notice here that I have used the quotation marks to show that the value being typed is going to be a string variable. And once I press enter, that variable has been created here. And we just have to go to edit to see that that variable has indeed been created, as you can see in our data set. At this point, we don't need to do any edits to the variables, that is to assign different names, because the command itself is easy as that. It actually already provides the name of the variable and also the value correctly. Now that we have all our variables in place, entering data is extremely easy. First, you must be working from the data editor in edit mode. So to open it, I'll just go ahead and type edit in the command and then press enter. Here, just enter the data in the exact same way as you would in Microsoft Word. Let's go ahead and enter the data that we have. At this point, you must have discovered how it's definitely not a good idea to enter data directly into STATA. One main reason is that it's not easy to correct when you make some mistakes. While you are in the data editor window, it's not possible to undo. So if you were very used to doing undo, let's say the Ctrl-Z command, it doesn't work. Which means if you make any mistake, you must remember where the mistake was made and then go back to edit that manually. If you already have data entered in STATA, you certainly want to avoid editing the data accidentally. That's why if we just want to see our data, we always open the data editor in browse mode. So to go to data editor in browse mode, you can either click on this button right here, data editor browse mode, or my favorite, just type browse in the command window. Now we have opened in browse mode. So here, I cannot be able to edit anything that I already have entered in the editor. And at this point, you obviously want to save the dataset that you have just created. So you can do that by simply clicking the save button here on the toolbar on the main window of STATA. I'll go to the folder where I want to save. Here, I'm just going to create a new folder. I'll call it data. And in that folder, let's just call this data entry. And then go ahead and save. So in the previous lessons, I shared with you why it is not a great idea to enter data directly into STATA. One of the most common formats for working with data is spreadsheets, Microsoft Excel being the most popular. So in this lesson, I will show you how you can bring data from Microsoft Excel. Here we have the dataset that we'd like to import opened in Microsoft Excel. The first thing you must do is to select all the data. So here, I'm just going to select the data like that. And then I right click and I choose to copy. Now let's head over to STATA. Here we first need to open the data editor in edit mode. So I can just issue my command edit and press enter. Perfect. Make sure you have selected the very first cell on the top left, which is where we are, and then right click and paste. STATA will ask you if the first row of the data are the variable names. In our case, the first row of our data from Microsoft Excel were names of each of the columns, and we would love to treat them as variable names in STATA. So we choose treat first row as variable names. And with just those few steps, our data is now in STATA. The next thing, of course, is to save the data set. So I'm just going to go ahead and click the save button at the top. And I'm just going to call this data import and click save. In the next lesson, we'll explore variable properties and we'll be using this same data. The next thing after you have imported data into STATA will be to edit your variables. There are many places in STATA where you can do this. However, we have a dedicated screen for editing variables called the Variables Manager, and that's what we'll be using in this lesson. To get to the Variables Manager, you can click here on the toolbar just next to these two buttons for the data editor. So here you can see the Variables Manager, or you can just use the command var manage. So here you will see that on the left, you have a table showing all the variables in the dataset and their properties. On the right-hand side, you have the properties of the variable that has been selected on the left-hand side here. So for example, ID is the first variable and it has been selected. That's why here on the variable properties, you're looking at properties for the ID variable. So when we imported the data from Microsoft Excel, almost all the variable properties were automatically set for us. The variable name is a unique name that you use for identifying the variable. In the previous lessons, I mentioned that the variable name cannot have spaces, symbols, and so on, among other rules. And if you notice here on the variable names, STATA has automatically removed all the spaces and symbols when creating the variables the time that we were importing the data from Microsoft Excel. The label is the display name of the variable. You can type the label anyhow you want with spaces, symbols, and all. The label is what's going to be used when you have output from your analysis. If the variable doesn't have one, it helps to type in the label here. And then once you've done that, go ahead and click apply here at the bottom. Next is the data type. In the previous lessons, I mentioned that you have two main data types, numeric and string or text. For our ID variable here, the data type says byte. That's the shortest form of numbers without decimals. When you import data from other programs, Excel will automatically set the correct data type for you. So changing this in most cases is not necessary. However, you can still learn more about data types by using help data_types. Next, we have the display format of the variables. The display format controls how the data is displayed in the data editor and in your results. For example, if you set the display format of a numeric variable to say %8.2f, what it means is that the data will be displayed with 8 characters maximum and 2 decimal points will be shown at all times. Display formats do not affect the underlying data. They are just about how the data is displayed. So in many cases, there's no need to change the format assigned by STATA when you imported your data. But you can still learn more about display formats using help format. Before I go, you notice that here on the types, if you click the drop down, you have many different types, but all the types that you have here are all about numerical data. So when you import your data from Microsoft Excel into STATA, STATA automatically assigns whether the variable is numeric or it's text. If it is numeric, then you have these options of the data types. If it's text, for example, in terms of the name of respondent, you notice here that you only have strl, which means you only have 2 options for string variables. So in other words, you cannot change a variable from string to numeric or from numeric to string by using the data type on the variable properties here. So far, if you inspect all the variables that we have so far, everything actually seems to be in order, except of course for value labels. We haven't talked about value labels and notes. So continuing with editing variables, let's look at the value labels. When recording data, we usually assign numbers to values for multiple choice questions. For example, for the variable sex, we will say 1 is male and 2 is female. In the data, only 1 and 2 are recorded. But when doing analysis, we need to show what these numbers stand for. In this case, 1 is male and 2 is female. We call these value labels. Right now, if I go to the data editor, in this case, I'm going to use the browse mode. So I'm just going to type browse in the command window and press enter. Now it's going to ask me if I want to switch from edit mode to browse mode because I already have the data editor in edit mode open right now. So yes, I want to switch to browse mode. And as you can see here, for the variable sex, we only have numbers 1 and 2, and highest education attained, we also have numbers 1 up to 5. I'm just going to go ahead and minimize this. Let's go back to the variable manager. In STATA, there are 2 steps for assigning value labels. We first need to create the value label sets, then we apply each set to a corresponding variable. Think of it this way. If you have a set of products in bottles, you first have to design and print the product labels. Then you apply it by sticking it on the bottle. You can design the value labels by clicking Manage next to Value Label. We'll be creating the value labels for sex variable. So we click Create Label. We must give this label set a name. In most cases, you will give the set the same name as the variable to which it applies. In this case, sex. So I'm just going to call it sex. The name of the value set must also not contain any spaces or symbols. It's much like a variable name. Then down here, we'll set the value and label pairs. We type 1 on value. And then here on the label, we say that's male and go ahead and click Add. Then we type 2. Here we say that's female. And once again, we click Add. Once you're done, you click OK. We now have our value label set. And when you click the plus sign here, you notice the values within the set. Let's create another set for highest education attained. We start with create label. Here, let's name this education. And then here we set 1, which is none. And then we press add. 2. Now I'm using the tab key to move from the box at the top to the box at the bottom. So the tab key, the label for that is primary. And I'll just use enter to enter that into this box here. Next is 3. That is for secondary. Again, press enter. And finally, we have 4 tab. This one is tertiary. And again, we press enter. We're done. We click OK. And you can see once again, we have this set here. Now we're done creating all our labels. So let's close this dialog box. Now all we need to do here is apply each value label set to its corresponding variable. First, we select the variable. So in this case, we'll start with the sex variable. Then here on value label, we click the drop down and select sex, and then we can click apply. So now that has been applied. The next is highest education attained. So first we need to select that variable. And then here on value label, click the drop down and select education, and then click apply. And again, that has been applied. So now let's inspect the data in the data editor window. Once again, we just type browse and press enter. So we are in the data editor in browse mode. Now you notice that for each of the variables, sex and highest education attained, instead of just 1s and 2s or just numbers, now we have the labels. Let's go back to the variables manager. I'm just gonna minimize this. And because I already have the command var manage, I can just double click it from the review pane here. And now you can see that we are back in the variables manager. The last thing that we have here is the notes. Notes are great when you will be collaborating with others, creating and using the dataset, and you need to remind them what this variable is about and how to use it. If you need to add notes to each variable, just click manage to the next of notes here. For example, here I'm going to select ID at the top. Then we click manage. And then you go ahead and click add. Then we type our note here. Once you're done typing in your note, you can click submit and then just go ahead and close it. You can see here, it says we have one note on the variable ID. If the dataset you would like to analyze in STATA came in SPSS format, there is a way to convert it to the STATA format. Unfortunately, it is not possible to open SPSS data files directly from STATA. However, within SPSS, there is an option allowing you to save an SPSS file as a STATA file. Let's take a look at that. Here we have this dataset open in SPSS. To save it as a STATA file, we click File, then Save As. Where it says Save As Type, we click the drop down, and then let's scroll down until we find the STATA options. So here we have lots of STATA options. My version of STATA is STATA version 13 standard edition, which is this one here. So I can just go ahead and select STATA version 13 SE, and then I have to give this file a name. I'll just call it data from SPSS. All right, then we can go ahead and click save. Awesome. So at this point, we have successfully saved the file as a STATA file. Now let's go into the folder and open it up. So within this folder, you can see we have data from SPSS right here as a STATA file. So we can just go ahead and double click to open it with STATA. And as you can see here, it's exactly the same data file. We can actually even go to browse to look at the data itself. And here it is. So far, all the commands we have been writing have been run through the command window. Now, the downside of this approach is that once we close the STATA program, all those commands will be lost, which means next time we want to run the same analysis, even on the same data, we'll have to start from scratch. It is considered good practice to always work from what we call a do file. A do file is a STATA file where you record all the commands that you're using. When you open a do file, you're able to run all the commands at once or each command one by one. Let's create a do file for use for everything else that we're going to be learning from now on. So on the toolbar here at the top, click on this button here that says New Do File Editor. Now, we'll first of all save this file by going to File, Save As, and let's just call this My Commands. And then I go ahead and click Save. Perfect. Now that we have our do file created, let's see how we can use it. So far, we know that to open the data editor in the browse mode, we can use the browse command. So let's type here browse. We also know that to open the variables manager, we use the var manage command. Let's type var manage. We can run the browse command by first of all selecting it, then click the execute button at the end of the toolbar here. So our command has worked. Let's go ahead and close this. The shortcut for the execute command is Ctrl D, and I'll be using that from now on. For example, here I can select this, press Ctrl and hold it, then add the D, and that's it, that command has been run. Again, let's just close this. It's always good practice to indicate what a piece of command is going to do. If you are passing the do file on to another person, they will find it easy to follow through by looking at the documentation you have added for each command in the do file. We call those pieces of documentation comments. Comments are blocks of content that will not be executed when you are running the do file. To add a comment, just type an asterisk first, then type your comment. For example, here let's say that this piece of code opens up the data editor in browse mode. You can see that all the comments will come up in green like this. Now let's say something about the var manage. Awesome. If I press Ctrl D without selecting any piece of code, you can see that the two commands have been run one after the other. But every time the comments will be ignored. In the previous lesson, I introduced you to the do file, which helps you document all the commands that you are using. What the do file doesn't do though is that it does not save your output. So everything being shown here on the results window will get lost as soon as we close the program. You might be asking then, what does this save button at the top do? Well, that saves changes made to the data file itself, but not the results. To save all the output on the results window, it is good practice to always use the STATA logs. Before you start running any analysis, make sure you have turned on the log option and that there is a file where all the results are being saved to. Once the log is on, everything that appears on the results window will be saved in the log file. To turn on the log, click the log button here at the top. Let's give the name of this log my output. And then click save. Now you notice here it says log on. Next time we open the STATA program, we can choose to create a new log or simply use the one that we already have. If you use an existing log file, you will have options to either override it or append the new output at the end of the file. We'll see this in action in later lessons. When you have been provided a dataset for analysis, it is useful to check what kind of data and variables it contains before you can start analyzing it. There are two commands that will come in handy in that regard. First, we have describe. Let's select and run it. As you can see on our output here, describe gives us information about the dataset in general. For example, all the variables that are listed here. So for example, here we know that we have 413 observations, we have 7 variables, and these are the variables. For example, here we can see information about ID, household monthly income, parental education. We have the variable names, storage type of the variable, the display types. If the variable has a value label set, some of these variables do have, and each label of each of the variable there. The other command that you're going to need is codebook. And what codebook does is it shows you in-depth information about each variable in the dataset. You can just run codebook without giving it any variable. And what happens when you do that, you notice now here, it's describing each of the variables one at a time. For example, we have the ID variable, which is a numeric variable and ranges from 1 to 450, which means the face value is 1 and then it goes all the way to 450. You have the number of values, which is 413. You have the units, and then you have missing. You don't have any missing, so that's 0 out of 413. It even gives you summary statistics like the mean, the standard deviation, and percentiles, especially if that variable is a numeric variable. And that's what's happening with all these others as well. You have household monthly income, which gives you the range of $70 to $490, and again gives you the mean and the standard deviation. Down here, we still have more information to see, so we have to click more, and you see that now we have even more. For example, here we have CBW, which is child birth weight, and again it gives us the values. And when we click more, we have birth weight class, which is showing us that it's a numeric variable, but it does have a label, and the values are just 1 and 2. And if you click more, we'll actually have more information. So you can see here that this information has been tabulated, showing us the number of people underweight, the number of people that are normal. If you scroll up, you see the same thing with the variable sex, whereby it's a numeric variable, yes, but it has a label, S, and it's giving us a tabulation or a breakdown of the frequencies for each of the labels that we have. So we know from here already that we have 215 males and 198 females. If you want to show only a single variable, you can also run codebook and giving it a variable name. So for example, here, if I say codebook and followed by the variable HMI, I can run this. And you notice now here, it has provided information about just a single variable, in this case, household monthly income. And now we have all this information here. So it's up to you whether you want to describe all the variables in the dataset by just providing codebook without the name of a variable. but you can also say codebook and follow it by the variable name, which is going to describe just that single variable. A few lessons back, I introduced you to descriptive statistics, which is a branch of statistics helping us to summarize or describe our data in a more meaningful way and explore relationships. It's always a good idea to start analyzing our data using descriptive statistics to get a deeper understanding of our sample. Sometimes we also use descriptive statistics to explore errors or assumptions in our data before we can run any inferential statistics. We have different kinds of descriptive statistics that we can run. We'll be guided by the type of variable that we are dealing with in our choice of the statistics to run. We'll start with categorical variables. When we were talking about the different types and measurement levels of variables, we drew a line between continuous variables and categorical variables. Categorical variables are so called because they put our observations into categories. In our dataset, we have, for example, sex of child, then we have birth weight class, and here at the top we have parents' highest education. These multiple choice questions are categorical variables. The nature of categorical variables is that no mathematical computation is possible or appropriate. So the best way to summarize them is through frequencies. Frequencies are counts of the different data values. For example, we might be interested to know how many male children there were and how many female children there were. Counts can also be presented as percentages of the total. For example, what's the percentage of males out of the total? In STATA, we use the tabulate command to get frequencies. Before we run the analysis, let's make sure that we are logging everything that's coming out of our results window. So what I would do is I'll go here at the top and click on the log begin, and I'm going to select the same log file that we created earlier on, and I'll click save. Here, I'm going to choose to append to the existing file so that everything that we are going to have new here on the results screen should be added below everything else that is already there in the file. So I click OK. Now let's tabulate the sex variable. I already have the command here, so I'm just going to select it like that and run it. From this table, we can see that we had 215 males and 198 females. And here in percentages, that's 52.06% males and 47.94% of females. Now let's find out more about the tabulate command by using help tabulate. First of all, there are these two types of tabulations. Tabulate one way is what we have done now, which is table frequencies for single variable. Tabulate two way, on the other hand, is for cross tabulations, and we'll be looking at that in a later lesson. From the syntax, we can see that the tabulate command must be followed by a single variable name, which will be tabulated. We have the usual if, in, and wait statements, which are all optional, and then we have the options after the comma here. Looking at the options that we have here, I think we can utilize the sort option when we have a large number of categories shown in the table. If you need a table of frequencies for multiple variables, then you can use the tab1 variant of the tabulate command. Here, it says var list instead of var name. So what it means is that you can give it more than one variable. And remember, we just space out the variables. Again, we also have the usual if, in, and wait statements, and then we have tab1 options. And if you scroll down, we have this section for the tab1 options, which also include the sort option. Now let's try some examples. I'm going to close this first. And we're going to bring back our do file. Let's tabulate the parent's highest education variable and include the sort option. So that is going to be tabulate PHE, that's a variable name for parent's highest education, and comma for the options, sort. Let's select that and run it. So you can see here that we have another table of frequencies. The frequencies have actually been sorted from the highest frequency to the lowest frequency. I think that's really useful. Now for another example, let's tabulate all our three categorical variables and include the sort option. Because we want to tabulate multiple variables at once, we have to use the tab1 command. Tab1, and then we can provide the name of the variables, so starting with sex, parent's highest education, the base weight class or BWC, comma, then we provide the sort option. Once again, let's select this and run it. And you can see that we have multiple tables of frequencies for all the variables that we have specified here. So now let's take a look at how you're going to present this information in your dissertation, thesis, or in your reports. First of all, here at the top, we have templates of the way we can present this using a statement. So for example, here you can plug in the percentage and say this percent of respondents in our sample were male, wow, and then plug in the other respondents that were female. Or you can say the sample consisted of, and you put a percentage of male and a percentage of female respondents, and then in the brackets, you can actually put the total N, which is the total number that we have here, 413. Or you can say the sample consisted of, then you plug in the number of males, and here in brackets, you have percentage of males. And here again, you put the number and then percentage female respondents, and at the end, you have the N is equal to the total N, which is the total number of respondents that you have in your data set. So let's go ahead and use this template here. So we're going to say the sample consisted of, so the N for male, that is the number of males, that's 215. So we can say 215 in brackets, that's 52.06 and percent male. And now let's do for female. So the N for female, that's 198. So 198, and in bracket, we have 47.94% female children. And then in brackets, we put the total N, which is 413. But we first of all have to type N, and then we can say equals 413. Now in APA format, the symbols like N are supposed to be in italic, so I have to format that as an italic like that. So the sample consisted of 215, that's 52.06% male, and 198 or 37.94% female children, and the total is 413. So that's perfectly fine. Now, how do we put that as a table? In APA format, the table is supposed to look like this, where you only have border at the top and the border just to separate the headers and the rest of the table. And then you have the categories here. And of course, at the end, you have this border at the end. So here we just plug in the frequencies. For example, for male, we know that that's 215. And the percentage for that is 52.06. And again, for females, we have 198, that's the frequency, and the percentage for that is 47.94. And having done that, it means everything is perfectly fine. You can actually grab this and put it in your report. One note when presenting information in tables in the APA format is it is advisable to use tables only when you're going to have more than one row. So in this case, we have two rows, male, female, so that actually makes a lot of sense. If that information can be represented in a single row, then just use the statement like we have done here. In the last two lessons, we saw how to summarize categorical variables using frequency tables through the tabulate and tab1 commands. But unlike categorical variables, continuous variables normally have numerous discrete values. For example, if you have 400 respondents tell you their monthly income, you might end up having over 100 different values of monthly income. If you summarize that into a table, we might end up with a very long table, say with 100 rows. Now that obviously defeats the whole purpose of data analysis, which is to communicate a story through your data with minimum numbers as possible. Hence, the goal of descriptive statistics for continuous variables is to describe your data by a single meaningful value. The best way to do this is by describing the central point of the data set. The premise behind this is that all naturally occurring phenomenon usually will have the most scores around the number at the middle of the values. The number at the middle is the typical value in the distribution. The assumption is that the majority of the data must be around that figure at the middle. There are several numbers that can be used to describe the central point of your data set. They are called measures of central tendency. You can also just call them averages. And these are the mean, the median, and the mode. Out of these, the mean and the median are the ones that are used the most. The mode, not so much. The mean is the number we get when we add all the values together and then divide that by the number of individual values that we have. The median, on the other hand, is the value at the exact center point of the data when we arrange it from the lowest to the highest. And the mode is just the most frequently occurring value. The command for summarizing continuous variables in STATA is called summarize. Let's summarize the household monthly income variable. Here on my do file, I already have the command that I need. So I'll just select it and run it. So from our output, OBS is just the total number of observations, which is 413. The mean is the value we get when we add all the numbers together and divide the result by how many values there are in the dataset. So here it is 203.39. The standard deviation is the average distance between each value in your dataset and the mean. It's part of the other type of descriptive statistics called measures of variability. We'll talk about those in a moment. The mean is the minimum or lowest value in the dataset, and the max is the maximum or the highest value in the dataset. So going by the mean, which is our only measure of central tendency that we have from this output, we can say that the typical household in our dataset earns $203.39 monthly. Now, let's explore the summarize function further by using help summarize. From the syntax, first we can see that we can use the shorthand SU instead of typing the whole summarize command. Summarize takes a var list, which means we can summarize multiple variables at once. But again, var list and everything else to the right-hand side is in square brackets, indicating that we can just type summarize without specifying the variable list. As I mentioned in earlier lessons, this will summarize all variables in the dataset all at once. We have the usual if, in, and wait statements. Then we have our options at the end after the comma. In the options, we can see here that the most important one that you're mostly going to be using is the detail option with the shorthand D. And what it does is it displays additional statistics. Let's go back and try that. Let's summarize the monthly household income variable, but this time let's add the detail option. So I'll just say SU HMI, detail. But again, I can just say D, and that's going to work as well. Now let's select this and run. Now, apart from the number of observations that we have here, the mean and the standard deviation, we now also have what are called the sum of weights, the variance, the skewness, and the kurtosis. We also have values at different percentiles. The most important of these percentiles, we have the 25th percentile, which is 110, and we have the 50th percentile, which is 180, and we have the 75th percentile, which is 280. The 50th percentile is what we know as the median, which is the value at exactly the center point of our distribution. Here, the lowest value is 70 here, which is the smallest value in the first percentile. And the maximum value is the largest number in the 99th percentile, which is 490. So if you go by the median, the typical household in the dataset earns $180 monthly. Now the question is, between the median and the mean, which one should we report as the central point of our data? The mean is the most inclusive of the two. It includes all values of the dataset in its calculation. This is why it is the most preferred. However, it is easily influenced by outliers. So outliers are values that are extremely low or extremely higher than the majority of a dataset. The mean is best used when the data doesn't have any outliers. The median is never influenced by outliers, so it is best used when the data has outliers. The central point of the data alone may not paint the full picture of the data. We also need to know how the data varies across the distribution. Let's take this as an example. If the average number of eggs that I ate in 10 days is 2, that could mean that I ate 2 eggs each day for 10 days. But that could also mean that I ate 20 eggs in a single day and none in 9 days. However, the dispersion in these two scenarios will be different. There are several measures that can show the dispersion of the data. And the most common and useful ones are the range, which is the maximum value subtracted by the minimum value. Then we also have the standard deviation, which, as we have seen, is the average of the distances between each value in the variable and the mean. From our output, the minimum is 70 and the maximum is 490, which means our range should be 490 minus 70, and that's 420. Our standard deviation is 104.13. Now, what does this mean? Remember that the mean is regarded as the central point of our data. We want to see how far on average each data point is from the mean. So what we do is we subtract every value from the mean, and then we get the average of those resulting values. Of course, unfortunately, this method will always result into 0. Now, to solve this, the differences are squared first. Then an average is calculated for those squared differences. Finally, we calculate the square root of the average so that the answer can be in the original units of the variable that we are trying to calculate. The answer is going to be what we call the standard deviation, which in simple terms is just an average of the differences between each value in the variable and the mean. If all values in a dataset are exactly the same, it means each one of those values is also the mean. So the standard deviation is going to be 0 because when we subtract each value from the mean, the answer will be 0. A bigger standard deviation in relation to the mean means that there are far more variations in the data. Hence, when we report a mean, we must also indicate the standard deviation to tell the reader whether the values that got us to the mean are close together or they are spread further apart using the standard deviation. You can say that the standard deviation tells us how representative the mean is. Now let's do a final example. Let's summarize child birth weight and child weight in months. So here, I'm going to say summarize, or just so we have CBW and then CAM, which is child age in months. All right, we select this and run it. And now we have results for both variables. So now let's take a look at how you're going to report your summary statistics in your reports, in your thesis, your dissertation. At the top, we have the way in which we can report that using a statement, and we have two templates here. For example, we can say the average and then mention the name of the variable. So the average, for example, household monthly income was, and then we plug in the value of the mean, and then in bracket, we'll say SD, which means standard deviation, equals, then we punch in the value of the standard deviation at the end. Or we can say the mean and mention the variable of the respondents was, and we mention the mean with a standard deviation of, and then we mention the standard deviation. So for example, we could say the mean household monthly income was $203.4 US with a standard deviation of 104.1 US dollars. Let me actually just type that out. So the mean household monthly income was, so let's just round it up to just $203. So we can say US dollar 203, all right? And then with a standard deviation of, then we mention the standard deviation, which is US dollars 104.1. And that's it. Full stop. Now, next, this is how you can represent the information in a table. We actually have here table 1, and then we have summary statistics of key variables, which is the caption for the table. And here we have the 3 variables that we are summarizing. If it was just a single variable, it means we would end up with just a single row. So in that case, you don't need to actually present that in a table, so you can just use the statement. But because we have several variables, then it makes sense to use a table like this. So we have the household monthly income, child birth weight in kgs, and child age in months. It's always good to indicate the units of the variables here. And then we have the mean and the standard deviation like that.